And of course, this is just one-dimensional. People do this for much higher dimensions.
Is sampling for the Gaussian ID is uniform or?
Right. So typically, Python, MATLAB, and many of these platforms have two random number generators. One is uniform between 0 and 1, and one is Gaussian. So you just call the Gaussian random number generator. Wait, maybe I misunderstood your question.
Right, so you need to pick the Gaussian from which you're going to sample.
Yeah. So you have you have a probability distribution that says what is the prior probability that any data I sample is going to come from one of these three Gaussians. So it's a three-dimensional discrete variable. Yeah.
Can you give an example of what this model would be? What would you be trained on?
If you want to do so, when we get to later on in the course, and we talk about supervised learning, which this is an instance of, we'll talk about things like clustering. We're going to cluster the data. So clustering is a hard assignment, right? Suppose you want to have a soft assignment, like given this data point, I want you to give me a probability of it belonging to cluster 1 versus cluster 2, and that's what this gives you. So a Gaussian mixture model, you can think of it as a probabilistic clustering model, or probabilistic clustering model.
So it would give you three different probabilities in this case, if there's three.
Yeah. So for example, if I say given that I've sampled this point. Given that this is my point, what is the probability that it came from cluster 1, cluster 2, cluster 3? And it's going to be high probability from cluster 3, low probability from clusters 1 and 2. And it'll make more sense in high-dimensional cases. In one-dimensional, everything's along a single line. But in high-dimensional cases, the cluster centers are going to be quite far apart. So for example, at this point, right? Given that I'm testing this point, condition on this point, there's some moderate probability it came from cluster 1. Some moderate probability came from cluster 2, very low probability came from cluster 3. Right? If you treat the Gaussian distributions as clusters, right? And again, we'll talk about clustering later on in the course. Those will be moving on. Okay, so here's another mixture model. It's called they're called topic models. This big one is called latent Dirichlet allocation. Well, latent Dirichlet allocation posits, and again, this is sorry, I should have mentioned. This is a plate diagram graphical model. What it basically means is that there are k replications of this variable and n replications of this variable. It is another plate diagram. Now, what this is basically saying is that documents. Here's this is just sort of a word description of a modeling assumption. Documents can be represented as mixtures of topics. There are k topics that you choose a priori typically, and topics can be represented as a mixture of words. So there are m documents, so that's this plate. Each document contains n words. And so we observe are the words. Each word corresponds to a single topic. And then every document has a mixture of topics. So how the sampling procedure for this model works is I first sample a topic distribution of a document. So 20% of the words in this document belongs to topic 1, 30% of the words in the document belong to topic 2, so on and so forth. And then for every word in the document, I sample a topic from this topic distribution, and then I sample the word from the word distribution of that topic. That sounds like a mouthful, and I'll give you an example. And I kid you not, I Google searched for latent Dirichlet allocation example, and the first result was an LDA analysis of Sarah Palin's emails. When she was governor. You could do it yourself right now to verify that I'm not lying. And so, given sort of a set of documents, of emails, the model automatically learned the word distributions of a number of topics. And so these are hand-labeled topics. So there seems to be a topic. So these are the topics. There seems to be a topic that corresponds to education and waste, presidential campaign, gas, wildlife, because that's a topic of great importance in Alaska. And so you can actually look at the word distribution of individual topics, right? The latent Dirichlet allocation model also posits that every document is a mixture of topics. And so what you can do is given a specific email the LDA model, the linear distribution allocation model, can give you a distribution saying, and again, this is just from this example. This email is basically saying, this word, given this document, email, this word, like this document likely is generated from a mixture of these two topics, right? And of the words of this document, these words specifically was generated from this topic. This word is generated from this topic. This word is generated from this topic. This came out of the LDA analysis. So in this way, you can use models. You can use these generative models to build a compact representation of what are the most sort of strongest statistics of the data that you can use for introspection. Right? Something like this, it's very revealing about sort of the distribution of topics that someone that writes about in their email correspondences that you may not get out of just looking at just the raw words. So the key assumption of linear distribution allocation is that documents are mixtures of topics, and every word it corresponds to is likely sampled from one of the topics. And given that assumption, you could draw inferences like this, which can be quite insightful. Yeah.
So each word can only be in one of the topics? Or
So if you can be Bayesian and say, what is the given that this is the document I see, what is the probability that this word came from this topic? And I'm just labeling, and so the person who did this analysis, and just copied off this website, labeled this word as red because there's a high probability that this word, according to the model, came from this topic. All of these words have some probability of coming from any of the topics. When they're especially strong or peaked on a certain topic, the person who did this analysis labeled it color-coded.
And so when you train this, you have to give it as a parameter the number of topics that it's going to look like?
The simplest version, yes. Again, you could be more meta. There's a method called a hierarchical theoretic process, which you can posit. You could have a distribution of a number of topics, and then train each one. You have the LDA topic model, and then you think that more number of topics is less likely, unless you see a lot of data suggesting that you should have more topics. But in the simplest case, you predefine the number of topics. The last example is a generative deep belief network, so a deep learning example. The basic idea is that this deep learning algorithm learned the statistics of artistic style, and then given some input image, it can remap that image. It can regenerate this image according to the artistic style of some other input image. So this is the input image. These are 3 artistic styles, and it regenerated, it resampled an image from this image according to this style. So this is probably, I don't know, one of the coolest examples of generative models in recent times. Certainly made a lot of headlines. Okay, just a recap of generative probabilistic models. It's a way of quantifying uncertainty in tolerant missing values. The model itself represents a summary of the data, right? It's a simplified representation of the test distribution, and you can use it for inspection. You can sample from it, and training typically involves maximum likelihood training, where you fit the model parameters to the data. Because it's a joint model that you're fitting to the data, it is not optimized for prediction accuracy. So you should not use any of these. I would advise against using any of these for the Kaggle competition. Okay, so next lecture, we're going to talk about hidden Markov models in depth, which is a sequence modeling problem. This will require knowledge of dynamic programming. So if you are not familiar with dynamic programming, I'll go over it tomorrow. Recitation on Thursday will recap dynamic programming for great generals. Okay, that's it.